Hello everyone, this is just a quick demo to show you how to use the standalone web app KASP plate reader analyzer to quickly analyze plate reader file to do genotype call for SNPs. So once you download the KASP cluster from my GitHub, you can double click the KASP cluster.html file to open it. You have a dark theme, or there's also dark theme, there's also light theme. You can change it, whichever you like. I will use the light theme here. So you can load up a plate reader CSV file or just drop it here. I only tested with the floor star omega micro plate reader files. That's the plate reader we have in the lab. So you can download the example here. You can also directly go to the GitHub, this folder. So I will show you one that is only one marker, all 384 wells, and another one with multiple markers on the same plate. Let's see the simple one. Let's just drag there. So this is the UI. You can see this is the theme. Load the different plate reader files or use example layout. This is finally after you finish it analyzing, you can download the final course. There's a threshold that you can use to control which marker, when the signal is too low, maybe the quality is not that good, you can filter them. This time all the wells looks good, yeah. So now it's easy, it's very good. This is HTTP1 marker, it's a very good marker. So this is on a collection material, so there's no heterozygous, either the homozygous B1A or B1B. So this will be the hex. I think it is B1B. This is the FAM. This is B1A. So that's it. The others you can leave as unknown. So this is using the normalized values. It's FAM divided by ROX and hex divided by ROX value. You can also use raw values to check the difference. So usually the normalized is better, the cluster is more tight here. And for selection, the default is like rectangle selection, but if they are too tight, the shape is difficult to use a rectangle, you can use the lasso select to do like a free shape selection, but you can turn this off by clicking it again. You can also zoom into one region by selecting this region, then click zoom to selection. It will go to the selection, then you can reset to go back. So this is just like a mimic of the class caller, the commercial software. It's very expensive as like a new lab for us, so that's why I just use Cloud Code to wrote this free software. So the class caller has the X correction, Y correction. So I think they didn't show you the algorithm. I think it's like just like a shear transformation. So you can click this to move them like more to the X, to the FAM, to the X axis, and the Y, to the weak or hex to the Y axis. Usually it's not necessary because the cluster is already good enough to see the difference. So once this is done, you can just download the course. Click it, it's a CSV file, so convert. Now this is this is 384 order. Usually our input is 96 DNA in the 96 plate. So I have another file. This is in the same repository in the folder you downloaded from GitHub, so I have this is 94 order, this is 1, 2, 3, 84 right now. So I can copy, I don't need this, I just copy this into here. Then I just sort the here, sort 96, then I have a plate 1, A1, B1, plate 2, until plate 4 here. So this is the genotype course, x-axis fam, y is hex. Then you can just convert it to like either A or B allele, or A1A or B1B, B1A or B1B allele in this region. So this is a simple one. So another usually for me, because I usually use 3D4 for genotyping KASP markers, because using 5 microliter reaction volume, the 384 usually give you better result. That's why I usually use 3D4 plate. I can use a part of this one time and then the rest another time. Or I just test the multiple markers on the same plate. So I will show you another example. So you can just refresh it to restart using this example, multiple SNPs. So for me, there's a different like template, right? You can have a quadrant A1, A2, B1, B2, but for me, because I use the 8-channel pipette to add a plate from 96 to 384, it's difficult to go to this way, like 1, 3, 4, like 1 to 1, 1, 2 to 3, 3 to 5. So for me, I just directly go to like one plate is 1 to 12, A1 to A12 is one plate, A13 to A24 is plate. I can put a tape here to hide the 13 to 24 to 1 to 12, so it's easy for me to add. So I have like A1 to A12 is one plate, 13 to 24 is a plate, then I go to B1 to B12 one plate, B13 to B24 is a plate. That's my 4 plates. This is also the plate, the 3D4 to 96 plate conversion I used in this Excel template. Like this is one plate to B1, B12, B13 to B24. Yeah, you can update it, this one to give it for your like order. So for me, I can show you. I have on A1, A2, I have like 5 markers or 7 markers. 7 markers. Each marker have 3 columns. B1, B2, I have 3 markers. Each one, like 1 to 6 is one marker, 7 to 12 one marker, 13 to 18 one marker. So I use this one as so when you can see it only show you the one show on the plate, not all the 3D4. But you can also hide all of them. To hide all of them, nothing to show. Then you just unhide the ones you want to show. I want to see this 1 to 6. I will unhide. I can see the cluster here. Yeah, that's it. Then I can hide all. Then to select 7 to 12, unhide 7 to 12, Y, X, Y, X, X. Yeah, that's it. For some reason, yeah, my 7, 8, it's all like not amplified. Maybe I forgot to add DNA samples or something, yeah. So then can hide all, start 13 to 18, and hide. Those markers are good because those are already tested markers. Just the same half plate DNA, 3 different markers. Then once you finish the, that's it. You can just then go to download the course, convert. Then I still copy this to here. To sort because mine is on B1, B2, so should be plate 3 and 4. So the others are unassigned. Go back, go to 3. Start there's genotype callings. 3, plate 3, plate 4 first, plate 3, plate 4. Yeah, that's it. Thank you very much. This is if this is not working for you for your plate reader output, you can send me an email with your output. I can tweak it to work for you. Thank you.